Hi, this is Math 1050, and this video is over Chapter 7E. In this chapter, we are looking at counting, which is how you find the total number of events when you're working with probability. And it all depends on what type of event you use. Now, there are equations for this, but there's some that you can get around the equation and use some calculators for. All right, so we'll just go through different situations. Um, First, arrangement with repetition, meaning that you can pick the same item twice or more. N is going to be what we use to determine the number of items. R is going to be the selections made from that list of items. So if we have 5 items and we're selecting 5 times, where we can select any of the items, your R is going to be 5, your N will also be 5. Right, so when we are selecting, we multiply our number of possibilities for each trial. So if we are selecting 5 times, let's say, and we have 5 numbers, so let's say N equals 5 and R is 5, and we'll have and will allow repetition. Then each selection is going to be allowed 5 times. And so we multiply all of these, and this is going to come out to be 5 to the 5th. 5 to the 5th is 3,125. So you have a total number of 3,125. Alright, so example, a byte is a sequence of 8 numbers that are either 0 or 1. And so you have 8 different numbers. So R would be 8. And of these numbers, you have 2 possible options, 0 or 1. So they all multiply each other. So you have 2 to the 8th, which is 256 times. Okay. Now we have what's called permutations. And this is n total number of items. And no item can be selected more than once. And the order at which they are selected matters. Alright, so in this case, the first item, you have n chances. You can select any of the n items. The next item, you have n minus 1 chances. Okay, because you can't select the one you selected first. And then the next one, you have n minus 2 chances, because you can't select the first 2. Eventually, you'll get down to selecting where you only have 2 items left and then 1 item left. All right, and so and here we end up selecting all items. Okay, and so this works out to an n factorial, which is just n times n minus 1 times n minus 2 times n minus 3 all the way down to 2 times 1. So if a history pop quiz asks a student to arrange the following presidents in chronological order: Hayes, Taft, Polk, Taylor, Grant, and Pierce. If an unprepared student decides to guess, what is the probability of guessing correctly? There's only one order that is correct, so the probability is going to be 1 over wherever the total is. The total is what we gotta find. Right, and so we have 6 possibilities. But once you select the president, you can't select the same one twice. So the first selection has 6 choices. Next selection has 5 choices, then 4, then 3, then 2, then 1. And so this becomes n factorial, which will be 6 factorial. And 6 factorial, that multiplier altogether is 720. So your probability of guessing correctly is 1 out of 720, which is 0.001 or 0.1%. In the next one, permutations with selections. Here, you're not selecting all, you're selecting a certain few. And it's still the total. We're not going to select any item more than once, and we're only selecting so many. So R will equal less than what n is. To calculate this, your total events will be n factorial over n minus r factorial. However, there is a calculator we have. So if we go to Blackboard, QR calculators, and go down to counting, the n factorial is also on here. So you put in what your n value is, you put in what your r value is, and then your NPR is your permutations, right? And so for this example, when testing a new drug, phase 1 involves only 8 volunteers. The objective is to assess the drug's safety. To be very cautious, you plan to treat the 8 subjects in sequence so that any particular adverse effect can allow for stopping the treatment before any other subjects are treated. If 10 volunteers are available and 8 of them are to be selected, how many different sequences of the 8 subjects are possible? So n equals 10, r equals 8. And so we'll go to a decimal calculator, put in 8 for n, put in, 8 for r, put in 10 for n, and we get a total permutation of 1,814,400. And so the probability that, of one specific order being obtained is 1 over that. All right, we do have permutations with repetitions here, and number of items are selected. Not all items the same, so there are k different items. So you have n1, which is the number of item 1, n2, which is the number of item 2, n3, which is the number of item 3, all the way up to nk, which is the number of item k. And so we have the total count being n factorial over n1 factorial, n2 factorial, n3 factorial, and so on. Right, so how many ways can the word repetition be rearranged? So we have R, E, P, T, I, T, I, O, and N. Okay, so 1 R, 2 E's, 1 P, 2 T's, 2 I's, 1 O, and 1 N. So you have a total of 1, 2, 3, 4, 5, 6, 7 different letters, and a total in the word 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our total count is 10 factorial over 1 factorial, 2 factorial for E, 1 factorial for P, 2 factorial for t and I, 1 factorial for O, and 1 factorial for n. All right. So 10 factorial, you can actually go to the Desmos calculator for that. 10 factorial is 3,628,800. And then 1 factorial is just 1, so we don't have to worry about those. 2 factorial is just 2, so we're dividing it by 2 3 times, which is going to be 8. So we get 3,628,000. Did I write that wrong? 800. Okay, the 0 didn't show up. 800 over 8. And we can do that. Calculator. And we get 453,600. Okay, that's how many different ways we can rearrange that word. Okay, combination. The order does not matter. So what you're doing is you're taking your permutation and you're dividing it by how many selections, factorial, and it determines the combination of it. So in the Pennsylvania match 6 lotto, winning the jackpot requires you to match 6 different numbers from 1 to 49. The winning numbers can be in any order. Find the probability of winning if one ticket is purchased. So here n is 6. I'm sorry, n goes from 1 to 49. So this number selection is 6. N is 49. R is 6. All right, so we have a calculator for that as well. N is 49. R is 6. And so notice the permutation's really high. I mean, this is 10 to the 10th, so that's about 10 billion there. The number of combinations, though, is 13,983,816. Okay. All right, so the probability then of winning would be 1 over that value, okay, which becomes about, let me get the division of it. A really low number. A lot of zeros here. That's the percent, 0.000007%. All right, now before we end this, I want to look at one more, and that's going to be combination versus permutation. Okay, we can kind of look at it for the last one, but I want to look at something that's a little bit smaller. Let's say n equals 3 and r equals 2. So you're selecting our 3 total 2 possibilities. Let's use letters for this. So let's just look at the word cab, C-A-B, and we're selecting 2 letters from each. So we can select CA, we can select CB, we can also select AB. We can select AC, we can select BC, and we can select BA. Okay, if we look on our Desmos calculator, we have 3 numbers, a selection of 2, and so we see permutation is 6, combination is 3. Okay, here is our combination. CA, CB, AB. AC is just CA written backwards. BC is just CB written backwards, and BA is just AB written backwards. These are 6 permutations. Right, so the permutations is going to be more. It's going to include either way of writing it. So CA is 1 permutation, AC is 1 permutation, but C and A is 1 combination. Doesn't matter which way we write it. That is the difference. Alright, and so that is the end of chapter 7. I will see you in the next chapter. Bye.